The flowerpot jungle, the tiny ecosystem living on apartment balconies. From the sidewalk below, an apartment balcony often looks simple: a railing, a chair, a few hanging boards, maybe a chilling vase building over the edge. But from the perspective of insects, birds, spiders, microbes, and tiny roots, that balcony can function like an entire elevated forest. It is a batch of life suspended above concrete, glass, traffic, and human routines. A miniature jungle built unintentionally in the sky. What makes balcony ecosystems so fascinating is their isolation. Unlike gardens connected to soil and larger landscapes, flower pots exist as islands. Each container holds its own climate, nutrient cycle, moisture rhythm, and food web. A single clay pot can become a self-contained biome, complete with decomposers, herbivores, predators, pollinators, and shelter zones. Multiply that across an apartment block, and the building becomes the vertical chain of hanging ecosystems. The first life in the system is usually invisible. Inside the potting soil, bacteria and fungi begin breaking down organic matter almost immediately. Fallen petals, dead roots, dry leaves, and spilled tea or coffee from human hands become nutrients. Moist soil creates ideal conditions for springtails, mice, fungus, gnat larvae, and microscopic worms. Even before the first insect lands on the leaves, the flower pot already contains the hidden underground ecosystem. The plant itself acts like a canopy layer. Broad leaves create shade over the soil, reducing evaporation and protecting tiny invertebrates below. Vines and stems create vertical climbing routes for ants and spiders. Flowers provide nectar and pollen for bees, hoverflies, and butterflies that can surprisingly locate the tiny sky islands even several floors above the street. A balcony jungle often begins with just one plant, but complexity grows quickly. Moisture from watering spills onto neighboring pots, creating humid corridors. Fallen leaves blow into corners and decompose. Algae may form in saucers beneath the pots. A forgotten packet of rainwater becomes a mosquito nursery. Webs stretch between railings and stands with thin wicks. What seemed decorative becomes ecological. The most important factor shaping the jungle is microclimate diversity. One side of the balcony may receive direct morning sun, creating warm, dry conditions perfect for succulents and sun-loving pollinators. Another corner remains shaded and humid, where moss, fungus, gnats, and tiny snails thrive. The railing edge may be windy and exposed, while the wall side stays still and protected. The range of microhabitats allows surprisingly high biodiversity in a very small space. Pollinators are among the most remarkable visitors. Bees navigating city streets, can detect balcony flowers from a distance using sand gels carried upward by warm air. Butterflies pause on lantana, jasmine, or basil blooms. Hoverflies patter heartboards. Even moths may arrive at night if the flowers release fragrance after sunset. For the insects, balconies function like nectar stations suspended between buildings. Predators quickly follow prey. Spiders anchor webs between plant stakes and railings, perfectly positioned when flying insects slow down to land. Small jumping spiders hunt aphids on leaf surfaces. Ladybugs may arrive if soft-bodied pests appear. Geckos on Guam balconies hunt moths drawn to indoor light spilling through glass doors. The balcony becomes layered just like a forest. Soft floor, leaf canopy, flower zone, predator protest. But sometimes treat balconies as safe ob- observation platforms. Sparrows land on railings to inspect spilled seeds or nesting fibers. Sunbursts and hummingbird-like nectar feeders in some regions may visit flowering pots. Pigeons use sheltered corners to rest. Through their droppings also enrich the nutrient cycle, feeding soil microbes below. Human behavior drives the rhythm of this ecosystem. Watering schedules create artificial rain cycles, pruning becomes canopy management, compost scraps added to pots accelerate decomposition, balcony lights extend insect activity into the night, even moving furniture changes wind flow, altering where spiders build webs and where leaves accumulate. Seasonality transforms the jungle repeatedly. In spring, fresh plumes trigger pollinator traffic. Summer heat intensifies evaporation, concentrating activity around shaded dam sources. Autumn leaves from nearby trees below onto balconies, enriching soil surfaces. Winter slows visible insect life but strengthens fungi and microbial dominance in moist spots. What makes the ecosystem cinematic is the contrast in scale. Below, the city moves in noise and speed. Above, on a balcony barely wider than a chair, a complete miniature rainforest of soil life, insects, roots, nectar, and predators continues unnoticed. Each flower pot is a tree island, each railing is a plant, each drip tree is a bond. Together, they create an elevated jungle state into urban architecture, and it is only the visible beginning. In part two, we will move deeper into the soil, trees, and zone to uncover the microbial rainforest beneath the flowers, where the balconies, smaller creatures quietly control the health of the entire sky ecosystem. Beneath the leaves, below the petals and decorative ceramic edges, the real balcony jungle begins in darkness. The soil inside a flower pot is not inert material as a dense living matrix of roots, fungi, microbes, decomposers, moisture pockets, and tiny invertebrates that together function like the rainforest floor of a miniature world. What looks like a handful of potting mixed in ecological terms, a compressed underground forest ecosystem suspended above the city. The moment water touches the soil, life accelerates. A balcony watering can, a house, or a sudden rainfall creates the equivalent of a tropical downpour for the organisms below. Dry particles swell, tiny air pockets fill with moisture, dormant bacteria awaken almost instantly, feeding on dissolved organic molecules from dead roots and fallen leaves. Fungal threads expand through softened soil channels, linking one root zone to another like an underground communication network. The fungal web is the micellar backbone of the flowerpot jungle. Five white threads weave invisibly through the soil, breaking down decaying plant matter into nutrients that roots can absorb. In larger balcony containers where several plants share the same soil, the fungal connections may allow nutrients and moisture to move from one root zone to another, creating a kind of cooperative underground economy. Around the fungal strands, microscopic predators appear. Nematodes glide through thin films of water between soil grains, feeding on bacteria or decaying organic matter. Protozoa consume microbes and release nutrients in forms plants can use. Springtails live across damp surfaces, feeding on mold and fungal spores. Soil mice patrol the upper layer like tiny forest scavengers. None of them are visible to the casual eye, yet together they regulate the health of the entire Balcony ecosystem. The tree beneath the port as another ecological layer, water that escapes the drainage hose collects here, creating a shallow seasonal pond. If left standing, the tree becomes one of the richest habitats on the balcony. Algae quickly coat the bottom. Mosquitoes may lay eggs in still water. Fungus gnat larvae exploit organic particles washed through the soil. Tiny worms or biofilm feeding organisms may emerge in only a few days. This tree is the balcony equivalent of a forest powder. Even when the water evaporates, a minor ring remains, along with organic residue from roots and microbes. The next watering reactivates the entire microhabitat. In warm weather, the refill cycles can happen daily, turning the saucer into a bouncing wetland beneath the pot. Root systems themselves create the architecture of the underground jungle. Thick roots act like tree trunks, while fine root hairs branch outward like vines. The hairs release sugars and organic compounds into the surrounding soil, feeding bacteria and fungi in exchange for nutrients. The zone immediately around active roots The hydrosphere is one of the most biologically active places in the entire balcony ecosystem. A fish feeding on leaves above can influence their underground life too. When a plant is dried, its roots may alter the compost they release, changing microbial communities below. In this way, a tiny insect on a mahogany flower can indirectly reshape the biology inside the pot itself. The soil surface acts as the forest floor literary layer, fallen petals, dead leaves, herb cuttings, and even crumbs from nearby human meals become detritus. Microbes begin decomposition almost immediately. Mold blooms after humid nights. Tiny beetles and mice feed on the softened fragments. If the balcony owner has composed tea leaves or fruit peels, the decomposition zone becomes even richer, sporting a far dense food web. Temperature varies dramatically within just a few centimeters of soil depth. The upper layer may dry and heat quickly under afternoon sun, while the deeper core remains cool and moisture that creates vertical habitat zones. Surface scavengers in dry litter, fungal-rich mid-layers, moisture specialists near the base, root feeders around the dense rhizosphere, aquatic organisms in the tray below. A single pot can therefore contain multiple stacked ecosystems. At night, the underground jungle becomes more active. Cooler air reduces evaporation, allowing springtails and mice to move closer to the surface. Snails or tiny slugs may emerge from hidden crevices in the balcony wall and feed on young shoots. Fungus nests hover low over damp soil, laying their eggs in organic rich patches. The balcony seems still, but the pots are alive with microscopic migration. Different plant species shape different soil ecosystems. Herbs like basil and mint release aromatic compounds that influence microbial communities. Flowering plants produce more pollen, petals, and nectar drips, feeding fungi and gnats. Succulent pots remain drier, favoring drought-tolerant microbes and fuel larvae. Fern containers create deep shade and moisture, often becoming hotspots for springtails and moss growth. The most beautiful ecological truth here is that human care becomes climate. Every watering season creates a monsoon, every gift day creates drought, overwatering forms wetlands, pruning as fallen biomass. Reporting causes landslides in the miniature soil world. The balcony gardener unknowingly acts at weather, disturbance, and nutrient cycle all at once. And because the ports are elevated high above the street, they become isolated islands subsoil biodiversity. Microbes arrive on roots from garden stores, on dust from open windows, on insects visiting flowers, and even on the saucer shoes stepping onto the balcony. Over time, each flowerpot developed their unique underground identity. What appears decorative is actually a living rainforest floor above the traffic. In part 3, we will rise back above the soil into the leaves, flowers, and railings, where insects, spiders, birds, and night visitors turn the balcony into a vertical wildlife corridor between buildings. Once we rise above the soil and leaves, the balcony reveals its most dynamic role. It is not just a garden, but a vertical wildlife corridor suspended between walls, windows, and open sky. In the fragmented ecosystem of a city, where paths are scattered and green spaces are interrupted by glass, concrete, and traffic, balconies become stepping stones for life. They allow insects, birds, spiders, and even small reptiles to move through urban space in ways most people never notice. A bee crossing a city block do not experience buildings the way humans do. To the bee, every balcony flower is nectar station, every herb pot a batch of scent, every vine covered railing a safe landing strip. A row of apartment balconies stacked along one tower can function like the canopy layers of a vertical forest. One floor offers pastel flowers, another has jasmine, another a chilling petals with a face that attract ladybugs. Together, they form a living ladder through the architecture. Butterflies use this corridor differently. Their movement is slower, more exploratory. Following balcony halfway up a building can become a temporary refuge where they rest, feed, and recover from heat rising off the streets below. One balcony works stores sunlight and releases gradually, creating thermally stable landing zones that many insects prefer in the cooler hours of morning and evening. Spiders transform the balcony corridor into a network of predator checkpoints. The spaces between plant stems, closed drying lights, railing, and furniture edges are perfect anchor points for webs. Flying insects drawn by flowers or indoor light often slow down near the structures, making them easy prey. Up weavers stretch elegant webs between hanging pots, while jumping spiders petal lips and window frames like active hunters. At dusk, this elevated jungle becomes even more alive. Light leaking through apartment windows acts like an artificial moon, attracting moths, gnats, and tiny flies from across the building face facade. The balcony turns into a night feeding platform. Geckos cling to warm gourds near lamps, snapping up insects. Bats in some cities may scoot close to upper floors where moth density increases. Even praying mantis sometimes appear on plant sticks, using the flowerpot jungle as an ambush zone. Pots are among the most charismatic users of this corridor. Sparrows perch on railings, scanning for crumbs, nesting fibers, or insects disturbed among the leaves. In some regions, sunbirds or hummingbirds visit balcony flowers, hovering briefly before darting away. Pigeons may use Sheltered ledges at rest stops during rooftop flights for fledgling birds learning to navigate the city. Balconies can become crucial intermediate landing zones between trees and rooftops. One of the most fascinating aspects of the corridor is behavioral memory. Animals remember youthful balconies. A bee that finds nectar returns repeatedly. A spider may rebuild webs in the same corner night after night because follow their reliably channels insects. Sparrows may revisit balconies where people scatter crumbs or where herb pots attract small prey. Over time, the balcony becomes part of an urban animal's mental map. The railing edge functions like a forest print layer. Ants travel along it in organized routes, sometimes moving between flowerpots, wall cracks, and neighboring balconies. Spiders use the underside for hidden riches. Small webs may insect corners for mud nest size. Wind-blown seeds lodge in accumulated dust near the joints, occasionally sprouting moss or tiny weeds after repeated watering splash. Clotheslines and hanging decorations add another aspect habitat tire. Wind charms attract curious birds. Hanging lanterns create night insect hotspots. Fabric left drying overnight may collect moths or two loving flies by morning. Even forgotten cardboard boxes stored in balcony corners can become nesting shelters for roaches, spiders, or solitary bees. Rain changes the wildlife corridor dramatically. Water dripping from upper balconies creates cascading moisture pots that insects follow. Spiders rebuild after storms, birds forage and softened soil and bird trays. Snails may emerge from work crevices, climbing pot edges to feed on damp leaves. The balcony briefly becomes part of a larger building-wide rain ecosystem, linking floor to floor through moisture. Human routines constantly reshape the corridor. Opening a window changes airflow, turning on a lamp orders insect traffic, rearranging pots creates new pathways or plots or once. A newly added flowering herb may suddenly attract pollinators that never visited before. In this sense, the balcony is not static habitat, it's a living corridor under continued architectural evolution. The most cinematic truth is that the wildlife roots exist between private human lives. Behind each glass door is a separate apartment, a separate routine, a separate story. Set outside the doors on narrow ledges and railings, a parallel network of bees, spiders, birds, geckos, and moths moves through the building as if it were a cliffside forest. Every balcony becomes a node, every plant pot becomes a stopover, every light becomes a beacon, every dwelling becomes a brand. Together, they create a suspended migration route thre- threading through the city skyline. In part 4, we'll bring all layers together: soil, flowers, insects, predators, and human care to reveal how apartment balconies can become micro reserves of biodiversity, shaping the ecological health of entire neighborhoods. When we step back and look at the full system, the apartment balcony is no longer just a decorative corner of human life. It becomes something far more meaningful, a micro reserve of biodiversity suspended in the urban sky in cities where natural habitats are fragmented by roads, glass towers, parking lots, and shared services. These tiny planted spaces can act as refuge, safe places where life persists, reproduce, feeds, and moves onward. What makes their refuge so powerful is not size, but density of function. A balcony only a few square meters wide can contain living soil, food webs, nectar sources for pollinators, moisture pond in trays, seed traps in corners, predator webs between dwellings, shelter zones behind pots, thermal perches for birds and insects, vertical pathways between floors. In ecological terms, this is astonishingly efficient habitat design. The balcony's greatest role is often as a survival bridge during urban scarcity. During hot summers, street level green spaces may dry out quickly under concrete heat. That shaded balcony pots still retain moisture, allowing flowers to bloom and insects to drink from those soil edges or take water. During rainy weeks, these same balconies offer covered ledges and dry railings where spiders, beetles, and birds can rest. For pollinators, balcony refuges may become critical. Bees moving through dense city blocks often rely on scattered flowering resources. A single blooming basil pot, lavender planter, or jasmine vine can provide enough nectar to support repeated visits through the day. When multiple balconies across a neighborhood contain flowers, the building network becomes a distributed pollinator sanctuary. That matters at the scale of the whole city. Urban biodiversity does not only depend on parks, it also depends on the countless private microhabitats created by residents. Flowerpots, herb trays, vines, water dishes, compost corners, and shaded zones. The balcony is one of the most accessible forms of citizen-made habitat. Birds also benefit in subtle but important way. Balcony plants attract insects, which in turn provide food for sparrows and small urban songbirds. Nesting fibers from dried leaves, coconut liners, or hanging pockets can be collected by birds building nests nearby. Safe railings offer observation points above street predators. For fledglings, balconies are often the first stable platforms between nest and open flying. Even species people rarely think about, such as solitary bees, lacewings, hoverflies, and mountains, make use balconies as reproductive space. Eggs laid on leaves hatch into predators that have control of its and fungus nests. Tiny webs insect stems for larvae. Spiders establish long-term web colonies that persist across seasons. The refuge becomes self-sustaining. One of the most fascinating ecological effects is the cooling influence of living balconies. Plants transpire moisture, reducing heat around walls and windows. It creates milder microclimates that benefit not only wildlife but also microbial communities in the soil and even human indoor comfort. In dense neighborhoods, many planted balconies collectively reduce the harsh thermal edges of building fixates. The balcony also acts as a genetic stepping stone, insects moving from one flowering pot to another carry pollen across neighborhoods. Seeds may arrive on bird feathers or in green currants, introducing new plant species into balcony pots. Beneficial microbes hike on roots, zoos, or visiting insects. Over time, the balcony refuge contributes to genetic exchange between otherwise isolated urban habitats. Human care determines whether the refuge flourishes or collapses. Consistent watering maintains wetlands in trace and moisture in soil. Diverse plant species widen the range of visitors, avoiding pesticides, preserves predator prey balance, leaving a corner slightly while allows spiders, moths, and decomposers to persist. Even simple choices like keeping a shallow water dish can transform a sterile balcony into a live sport node. The beauty of the ecosystem is that it is built through ordinary habits, watering herbs before breakfast, trimming dead leaves on weekends, letting pasture flower instead of harvesting it early, forgetting a tray of rainwater after a storm. The everyday acts unintentionally shape the survival chances of dozens of tiny species. Across an apartment tower, dozens or hundreds of balconies can merge into a vertical biodiversity reserve. One resident grows flowers, another keeps herbs, another has vines and moss. Together, the facade becomes a layered living cliff full of feeding points, nesting material, water pockets, and predator perches. At night, most visit plumes near warm windows. At dawn, sparrows inspect railings. At noon, bees move floor to floor. After rain, snails emerge from shaded corners in the soil below. Fungi continue their quiet work. The balcony never truly sleeps. This is what makes the Flowerpot jungle such a perfect story for the hidden ecosystem served everyday places series. It reveals that even the private domestic spaces can become active participants in urban ecology. The city's biodiversity is not only impacts rivers or rooftop gardens. It's also in the page support outside kitchen door, the spider web beside chair, the bee poaching a fit flower, and the damp soil beneath a hanging fern. The balcony teaches a profound ecological truth. Small pieces can carry large life. A flowerpot is a forest floor, a railing is a branch, a window light is a moon, a balcony tower is a cliffside jungle, and in the middle of traffic, class, and noise, the suspended refugees quietly keep the city alive.